Today we are going to talk about the presence of zinc in blast furnace and its effect on fuel rate. As you can see, zinc is present in forms of oxide and all primarily three oxide and one sulfide has been mentioned in the slide. As you can see, primarily the reduction reaction, which is the main reaction that can gives us insight about how the zinc behave in the blast furnace. And primarily, as you can show, that reduction reaction has been mentioned in this slide along with the zinc vapor deposition phenomena. Subsequently, it has mentioned. Coming to the impact on the blast furnace operation, as you can see, this zinc gasify in between 900 to 1100 degrees centigrade, and this gasified zinc gets accumulated in the upper area of stack and form a sort of accretion, and consequently furnace lose its symmetrical cross section. This causes unsymmetric condition of the furnace as far the body descent is concerned, and once unsymmetric condition in the stack occur, there is a indifferent, non-uniform gas utilization across the blast furnace. This hampers severely the final melt out and the consistency of the process. Coming to the zinc and its ill effect, other one is the volume expansion of zinc. As we can see that zinc and refractory, if you compare the expansion potential, then we can see zinc almost have got a more than 3 times expansion potential compared to the refractory, and this creates a huge problem for the refractory where this zinc hide it itself. As in this illustration, it is very clear in observing linear expansivity of zinc and refractory, and it is concluded from this illustration that the linear expansion of zinc is almost more than 3 times, and hence this expansion potential create a huge problem for the refractory. In order to have a remedial solution, maintaining top temperature of the blast furnace is a good solution where with the peripheral gas movement we can drive out the zinc along with top gas. So this is a good solution. Apart from that, the zinc dissolution in form of unprepared burden when this sort of accretion or buildup, peel off or collapse in the blast furnace also hindered the molten metal in the hearth, and it create a lot of process upset as well. Majorly are tear or copper loss. Apart from these, we can say that metal hot metal temperature and compositional variance. So this all sort of process upsets is expected during this phenomena. And as this phenomena is keep on going due to this recycle and recirculation of this zinc vapor, we must not forget that this circulation phenomena is directly proportional to the burden duration in the furnace, the value of fume loading, that is what the zinc loading, and the upper shaft temperature. Hence, operator must have to look into all these three components while maintaining recycle and recirculation activity of zinc in blast furnace. And by observing, by focusing on this recycling and recirculation phenomena more closely will help in taking care of process upset created in blast furnace due to this activity. This is one of the standards where a operator should meet or focus around the scale where primarily loading is limited to 0.15 to zero point 0.5 kg per ton hot metal, and around these our ill outcomes for the furnaces are minimal. So this scale is pretty important. Thus, focusing on the scale and acting in area of recirculation load of zinc and its prevention helps in taking care of all process upsets created by zinc. Thank you.